Welcome everybody to today's webinar about 5 ways that sensing technology can make buildings healthier and more productive. My name is Uri Kogan. I'm the Vice President of Product Marketing here at R0. I want to start by talking about how buildings need to keep up. What does that even mean? To keep up with the changes in our society and in how we want to work and interact in our buildings. Then we'll talk about an overview of different kinds of sensing technology. I promise not to get too technical, but just to give you a sense of what's available. Then we'll talk about the core part of the agenda, which is how sensing can help your buildings keep up with the changes in what we need our buildings to do. We'll talk about a sensing maturity model that you can use to ascertain where you currently fit relative to potential and opportunity and help to devise what the next steps might be for you and your organization. We'll then talk about some key considerations to keep in mind as you are thinking about deploying sensing technology. And then we'll wrap up with a little bit just about R0, just so you have a little bit of context about what we do. If you go back to the early part of the last century, when telephones, cars, electricity, stove, and lots of other domestic technologies were coming into their own, it took decades and decades for those really to penetrate the market at a very high rate. More recently, in the last few decades, the internet, smartphones, social media, or even things like ChatGPT have reached penetration at a much, much faster rate. So we're seeing that technology adoption is faster than ever. And that, of course, changes how we work and how we interact with the space around us. It changes our behavior in a very rapid fashion. At the same time, our buildings aren't changing very quickly. In fact, they're changing more slowly than they have in the past. So this shows that 100 years ago, they were adding 30 to 40 floors per year as they were constructing new tall buildings. And over time, that has come down to the point where in the last decade, we're adding less than 20 floors per year. Construction is getting, of course, more complex, more sophisticated, but it's also slowing down in the process. At the same time that we need our buildings to change to reflect new technologies, new behaviors, our buildings are changing more slowly than they have in the past. Hybrid work is obviously a very current hot topic. Labor shortages that have emerged in a variety of domains, rising energy costs, all of these things are affecting how and where and to what degree we're able to be successful in our work. We need our buildings to be more responsive to our needs. But the building shell itself lasts for decades, sometimes centuries, without dramatic changes. The mechanical systems that we rely on to keep us comfortable in buildings typically have a lifespan of 10, 15, 20 years. The way that we configure space is often changing from year to year, in some cases even from quarter to quarter. The services that we rely on, whether those are janitorial services, EVS teams in healthcare, cafeteria services, et cetera, those might be changing from day to day based on how many people are in the space. And from minute to minute, really, we need to be able to adapt our environment for changes in behavior. I need a conference room. I need a focus booth to work, changes in comfort, and changes in risk, like the risk of infection based on how densely occupied a particular space is or how much ventilation is coming in. So our buildings need to be able to be responsive, but large aspects of the physical attributes of our buildings are really not responsive at all. They have a very long lifespan and don't change very quickly. So the way to get around this is to really use sensing to essentially wrap our buildings in intelligence that allows us to operate them in a way that reflects what people need. And that's how we can go from a building that maybe was built decades ago and was originally used in a way that feels very outdated now to an environment that is working in our modern context and making us productive and satisfied and able to achieve what we want to achieve. So hopefully I've convinced you that sensing has a role, an important role in helping to shape our built environment and make it reflect in a more immediate way what we need from it than just thinking about changing to that built environment, which is a much slower process. Let's dig in a little bit more to what kind of sensing might help us do that. So I want to talk about 4 types of sensing. Sensing presence, which is essentially, is there anyone here? Sensing occupancy, how many people are here? Sensing air quality, and sensing environmental quality. So let's just explain a little bit about each of those. So now we're just going to go through a little bit of kind of a technology background to give you a sense of these different types of technologies. So first of all, we'll talk about presence detection. And that's really just asking the question, is anybody in the space? Just as an example, a tangible example of what these different kinds of sensing really are all about. So we have a product that lets you sense whether somebody's in a room. That could be a conference room or an open area. That covers about 300 square feet. If somebody is within that detection zone, or multiple people are in that detection zone, we will get a positive response from the sensor. We also have a version that works for desks. So is somebody actually using this particular desk, which is great for desks or focus booths where you only really ever expect one person to be there. Then the next kind of sensing I want to talk about is counting. how many people are in your space, and also factoring in other things that aren't people in your space. So there's really a couple of flavors of this. The first one on the left is using infrared light, basically a thermal image, to understand and interpret how many people are in a space. So this is an example of a thermal image, and the algorithm that the sensor is programmed with can identify that there are 6 people around this table and report that number. There are currently 6 people in conference room A or whatever. And this is a combination of infrared cameras and the algorithm, the artificial intelligence that's programmed into the sensor to be able to make that interpretation. The other option is to use visible light. Again, you're using an algorithm to identify how many people are in that space, but you are also able to identify other things that don't have a heat signature, like laptops, jackets, backpacks, for example. And this allows you to determine things like passive occupancy. Passive occupancy is really important in office settings, for example, where people might drop into a focus booth and then leave their laptop there or their jacket to hold that space while they go into a meeting and come back. And the consequence of that is that somebody else walks by who needs a focus booth, but sees somebody's left something in one and thinks that it's occupied, then they can't use it. If you are able to detect this kind of passive occupancy and connect it to your calendaring system, you can actually free that space up, say after 5 minutes or 10 minutes, determine that actually there's nobody using the space, somebody's holding it against our policies, we'll release it back so somebody else can take advantage. And that's a great way to basically create more space or more usability of the spaces you already have. And I do want to also note that both of these images are training images. They're not images that are getting passed by the sensor to our cloud in any way. The only thing that's getting passed to our cloud is a timestamp, a location, and a number of people and or laptops or other objects. So this is not representative of the data that is getting passed into our system because we care a great deal about privacy and security. And as we'll talk about later, frankly, we care a great deal about minimizing the amount of data that is in transit between our sensors and the cloud. And one other thing I should have mentioned here is threshold detection. So the same technology can also be used to manage or to measure how many people are passing a particular threshold, like the entrance to a floor, exit off of an elevator, etc. And that's great for use cases where you are not as focused about where people are, but just how many people are in that larger unit of space. Next, I want to talk about air and environmental quality monitoring. I've combined these two into the same slide and highlight really 3 categories of measurements. The first is standard measurements like temperature, humidity, carbon dioxide, etc., that are about comfort, that represent assuring that your HVAC system is actually working to deliver enough oxygen to people in your space. There are more advanced indoor air quality measures like smaller and larger particulate matter. That's 1 in 10 microns here. Standard metric includes 2.5. And those are great for measuring things like combustion particles or harmful gases that are emitted by building materials and cleaning materials like formaldehyde. That can be great if you're fitting out a new space, you're bringing in a lot of furniture, and when you unwrap that furniture, you have that new furniture smell, maybe you want to let that dissipate for a week. And so if you're measuring formaldehyde levels, you'll know when your space is ready for occupancy. And then lastly, environmental quality measures. This is not really about the air, but light, noise, pressure, those are great metrics that also impact comfort and that, in fact, impact the choices of spaces that people want to occupy, which we'll talk about a little bit more later. So you're using sensors to understand presence and occupancy and indoor air quality and environmental quality. You need to get that data to the cloud. So pretty much everybody has some type of hub that is where that data flows locally and then connects that data up to the web. And that can be with a cell signal, an Ethernet connection, or Wi-Fi. And it allows you to both connect that data and send it up to the web for analysis. And it also allows you to monitor and manage that sensor fleet. So if you have thousands of sensors deployed across a bunch of buildings, you want to know if any of them are having any issues so that you can remedy that. By having a single network connection as opposed to having each sensor connect directly, you are reducing the number of connecting points. That reduces the risk of disruption to the existing network. If you walk into a building and add 4,000 new connections to the Wi-Fi system, that's definitely going to cause a disruption or at least an adjustment for that system. It lowers the IT security risk because you have 1 point of security concerns. And it also allows those endpoints, those sensors, to operate in a much lower power mode because they don't have to send a Wi-Fi signal. They don't need to have a cell signal. They only need to be able to send small amounts of data with low powered Bluetooth connections. So if any of you have smart home devices, like for example, a smart door lock, typically there's a hub that you plug in somewhere nearby. That door lock is connected to the hub with low power Bluetooth and is battery powered, so it can run for a long time. And that hub is what connects to the Wi-Fi and takes care of the connectivity. Our sensors work in the same way. Having a low power edge device eliminates the need for wiring and enables you to have very long battery life to reduce installation and maintenance costs dramatically. One other thing to note, it's important to take into account the ratio of hubs to sensors. For example, there are vendors that will require one hub for every 5 sensors. There are vendors that will require one for every 100. Obviously, that's a 20x difference in the number of hubs that you need. That can have a significant impact on the setup and cost of your system. Lastly, a lot of these sensing technologies are able to connect to your existing building systems in some way, but it's optional. And that's really important because, as we talked about, those mechanical systems and the software that runs them, they're typically upgraded very slowly, 10, 15-year cycles. And many of those systems are fairly out of date in terms of how their integration paradigms work. So if you don't need to integrate into a building system, you can get going much more quickly. Your cost of setup is going to be dramatically lower. Most sensing vendors really don't rely on that integration to drive value. If you do integrate, as we'll talk about, it can drive a lot of additional value, but it's important to know that you can get started without that requirement and get a lot of value and then incorporate that over time. So let's talk about some of the use cases for this technology. First of all, analyzing and optimizing how you use space over time. So this is all about measuring what's the utilization of different kinds of space in my portfolio or in my building, which kinds of spaces are used the most, the least, have the highest or lowest peak usage. It's all about making sure that you're able to provide the kinds of space that people need and to reduce the kinds of space that people don't need. I want to give you a couple of real examples to illustrate that. One example is at a customer of ours in Australia. And this was a bank that had 4 floors of a headquarters building and about 1,300 desks across those 4 floors. And they also had teams that were complaining that they needed more space, that they had a hard time finding a desk or a conference room. And by putting sensors on all of those desks and open areas, we were able to determine that actually they were only operating at about 66% peak. And they had about 300 or a little bit more than 300 desks available every day that weren't getting used. They just weren't easy to find for people who were looking for them. By putting the sensors in place and using that to reconfigure departments and implement a desk reservation system, they were able to get much more usage out of the space they already had. They went from a 66% peak to a 95% peak after. And that allowed them to essentially avoid leasing another floor in the building, which would have cost them about $5 million. So that's an enormous savings simply from using the space they already have a little bit better by understanding exactly what space they needed and where they needed it and making it easy to find space that you need. Similarly, at a tech company here in the US, they were growing really quickly and their facilities team could not acquire space fast enough to support the growth in their employee base. So what they wanted to do was use sensors to constantly look for spaces that were being underutilized and redeploy them into the kinds of spaces that they needed most. They put 4,000 sensors across their campus and they discovered that phone booths were consistently the most valuable, most occupied meeting rooms, much less so. Very clearly, the guidance from this is we should reduce the number of meeting rooms and convert a bunch of those into phone booths so that people have more space for those one-on-one conversations over Zoom or focus rooms where they can work on something on their own, whatever it might be. And they did this process every single quarter to optimize and adjust the kinds of spaces that they had. And that enabled them to grow the number of people on that campus by 20% without adding a single square foot. There's also value in this data in real time, in putting that data into the hands of users so that they can make decisions that help them get what they want done. For example, as you can see in this visual, you're looking across the space and finding a space that is available, or you get a notification when it becomes available. So this is about making space available to people in real time, making it easy for them to find spaces that they need. This can also not just relate to whether space is available or not, but also characteristics of that space. We're all used to looking for a conference room that's the right size for our group, but this could also be, I'm looking for a space that's quiet, or I'm looking for a space that's bright or a little darker because I have a headache, whatever it might be, helping people find the spaces that work for whatever they're trying to do and whatever their preferences are. Let's turn to an example from a hospital of using this same kind of data to drive a more effective cleaning protocol for the EVS team. This could just as easily work for a janitorial team in an office environment, but this particular example is really written more in the hospital context. So every day you have different treatment rooms that may be very busy or maybe aren't. In some cases, in some facilities, certain banks of rooms are used by a particular physician. If they're out of town on vacation, they're off that day, those rooms don't get used at all. But the EVS team may not really know which rooms are which. So they may be spending just as much time cleaning a room that didn't get any use as a room that had a full bank of patients coming in and out all day long. And that really doesn't make a lot of sense. If you're able to monitor the occupancy over the course of the day, you're able to understand which spaces really need their attention and guide your team accordingly. Secondly, you can measure real-time disinfection. If you're just doing manual disinfection after hours, let's say between the hours of 7 and 9, you can actually see which rooms which room somebody cycled into and how long they were there, and ensure that if your protocol says you should spend 20 minutes cleaning this particular space, that's actually happening and people aren't just going in, coming out, or not going in at all. If you're using UV disinfection, especially mobile towers, you can also validate that they've run. You can validate how long they've run and ensure that meets the protocol that you're intending. And then over time, if you're measuring the same kind of data over the course of a month or a quarter or a year, you can identify that there are certain spaces, maybe it's a particular waiting room, maybe it's a particular treatment room, that are consistently very heavily occupied and in use. And those might be spaces where you want to install a more permanent type of continuous disinfection solution. So let's turn to now to talk about air quality. And I want to talk about noise first. And I already talked about this a little bit, but noise is not really about the air, although maybe literally it is, because that's how noise works, right? It's waves in the air. But it's not really about how good the air is. It's really about, is this a comfortable place for me? Is this area that I'm trying to understand, why is it not popular? Is it because it's too noisy? Maybe we installed more glass than we should have, not enough acoustical panels, so people don't like operating in that space. Maybe conversely, we intended to create a quiet space with a lot of soft surfaces and acoustical panels, but it's not actually meeting our objectives. So measuring noise can be helpful in understanding whether the space is what we expect of it. It's also something you can use to search as a employee looking for space. Do I want a loud space? Do I want a quiet space? Similarly with light, do I want a dark or brighter space? Those are preferences that if you're measuring them, you can factor into booking systems to enable people to find spaces that are appropriate and valuable for them. Let's talk about particulate matter. So particulate matter comes in different sizes. The smallest particles are under a micron, and that can be things like dust and combustion particles, bacteria and viruses. So if you see that spiking, it tells you maybe you need a new air filter. But then you have slightly larger particles, like 2.5 micron in size, pollen, mold spores, other organic particles that might indicate that there's outdoor pollution, that you need to turn down your outdoor air damper if those are spiking. And then larger particles like 10 micron in size are typically coarser dust and organic particles that might indicate, again, a need for more cleaning or some other remediation. So measuring particulate matter is a great way to understand whether the space is delivering the kind of air quality that your employees need. And lastly, formaldehyde, I think we already touched on this, but if you're fitting out a new space, formaldehyde is commonly found in pressure-treated wood, like particle board. It's found in a lot of soft furnishings. So measuring formaldehyde can help to tell you when a space has off gas and is ready for occupancy, as well as maybe telling you, hey, this new furniture we bought really is off gassing more than we expected. Let's not buy that again. Let's look for a different vendor. These, of course, are just examples. There's lots of other ways to use air quality, but just wanted to highlight some examples. And then the last topic I want to talk about is infection risk. And in a typical 100-person office, you have all kinds of different space types. Some of those that are densely packed, where people spend a lot of time, where people might be more social or exerting themselves, like large conference rooms, cafeterias, fitness areas, they're going to have higher risk as compared to areas where people are more sparsely packed, where people are passing through and not spending significant time, or where they're just quiet and still. Those are going to have relatively low risk. Now, this is a very broad generalization. If you're using occupancy data, you can measure more precisely what's going on with dwell times, with density of people, and refine your understanding of infection risk. If you're using indoor air quality data, you can get even better. You can understand how effectively is my HVAC system working to deliver clean air to the space. And then you can modulate between the occupancy and the HVAC to really refine your understanding of risk, and then address areas that have higher risk, perhaps with UV disinfection or other means. So we've talked about the need for a sort of sensing wrapper around our buildings because the buildings themselves change slowly. We've talked about what some of the different kinds of sensing are, just as an overview of the technology. And we've talked about some of the use cases for sensing that can help you create spaces that are more effective and healthier for your organization. Let's talk about a sensing maturity model now to help you calibrate how far along you are in your sensing maturity and maybe what some of the next steps might be. So there's really 4 stages in our model. The first is a basic, where you're essentially ignorant. You're not using sensing to inform anything. You have essentially a dumb building. Dumb here is a double meaning. It's both dumb as in quiet, it's not telling you anything, and dumb as in not very smart because you're not able to do anything. You might have a building management system, but you don't really know what it's doing. Second is an experimental phase where you have a building management system, but it's hard to work with. So you're not doing much to integrate with that. And to the extent that you're doing improvement projects, you're doing it one-on-one based on inputs that are not coming from sensors. Maybe people are complaining. Maybe you have different organizational priorities that are driving changes that you're making to your space. And then the third category is systematic but siloed. So you have a BMS that's controlling your lighting and your HVAC, and maybe you're even adjusting ventilation based on CO2, which is often something that building management system will sell you as an addition. And maybe you're even doing occupancy sensing to inform long-term space planning. But these different projects and sensing systems are operating in silos. They're not really working as a cohesive whole. If you are working with all of this technology as a cohesive whole, that's when you reach this nirvana of an integrated and transformational approach, where you have continuous and comprehensive coverage of occupancy, indoor air quality, and HVAC all linked together to optimize and deliver the best possible experience for the people in your building. I think that most organizations are probably in step 2 or in step 1. There aren't that many that are at step 3, and really very rarely are folks in step 4. So as I go through the rest of this, think through maybe where you think you fit and maybe what some of the potential opportunities are if you move to the right. So let's talk about what it feels like to be at this basic phase. So at this basic phase, some of the areas in your building maybe feel overcrowded, others might be empty, but this is an anecdotal experience that you have. You're getting complaints from the sales team that they don't have enough space, so you're signing a lease to expand. It's hard to find a phone booth. Many people seem to squat in them. They leave their jacket just to save their spot. From an air quality perspective, when we have big meetings, people seem to struggle to keep their focus after a couple of hours. Maybe something in the air is part of that. And everybody's afraid of Sneezy Jane. She says it's just allergies, but people are leery of her because they're not sure how safe they are being near her. There's a stuffy conference room that no one ever wants to book. The third floor always seems too cold, so people who work there are smuggling in space heaters that are fire hazards and energy hogs in order to make it a little bit more comfortable for themselves. And the engineering team has been complaining that they're sitting next to the sales team who are really noisy because they're on the phone all day, and they find that to be distracting. If any of those stories resonate with you, this is probably the stage that you're in. So now let's talk about moving into the experimental phase. So at this phase, you might be trying to change the set points on that third floor that's always cold. You have a sense that maybe those thermostats aren't properly calibrated, which is why the heat isn't coming on. They're reporting a higher temperature than is actually there. So you've actually lowered the set point so that the heat kicks on sooner and heats up that space. And people seem to be happy about that. But you don't really know if it's the thermostat or some other issue. As you move into a more systematic approach, you're starting to do some of the things that we talked about in the earlier examples. So you're measuring utilization rates by space type for planning purposes, and you're able to email the organization to let them know when there's extra space available on the floor. You're counting how many people are using different kinds of space, and you're able to reconfigure your space every quarter to ensure that you're providing the best possible experience and the right kind of space types for folks. You removed the hot desks on the fourth floor that were rarely being used. You added phone booths. You have a sense that squatting is common in certain spaces, but you haven't really figured out how to do anything about that. On the air quality side, you've identified spaces with bad air quality. You went and investigated and found blocked air vents. You found some that needed a damper to be replaced to ensure airflow, and that's helped. You have this big meeting room where these meetings are happening, where people are getting sleepy after lunch. And because now you're measuring CO2, you realize that CO2 is spiking there when the occupancy is high because BMS is not delivering sufficient air to that space. So you've adjusted that, and that's helped. And then you also you added more temperature sensors on that third floor, which did confirm that the thermostats were not calibrated properly. You fixed that, and now the temperature is comfortable and back to the set point that your organization intends. And lastly, on the environmental quality side, that engineering team that was complaining about how noisy the sales team is, you measured and determined that yes, that is in fact true. They operate at very different noise levels. So you've moved them to the opposite ends of the floor, and everybody seems much happier about it. At the last stage of maturity, you're able to do even more innovative things. So you're able to connect your space booking and calendaring applications to presence and occupancy and passive occupancy detection so that people can actually find the spaces that work for them in real time. And any space that is booked but is not actively occupied by a human being for 5 or 10 minutes gets sent back into the booking system as available for somebody else to use. And because of that, people tend not to squat because they know that space. They may come back and discover that somebody has put their backpack on the outside of the room and is now using it. So people are also changing how they behave into being more careful about claiming space and then not using it. Every part of the building now meets the corporate air quality and comfort standards. And if there are any issues, we get alerted about it before somebody comes and complains, which is great because it reduces the number of complaints. People are generally happier. And we discovered a bunch of spaces that were overventilated, especially when they weren't fully occupied. Now we're able to dial back the HVAC accordingly, which saves us 15% on our HVAC costs over the last year. From an infection risk point of view, we've added continuous disinfection in shared spaces that are high risk and in areas that have high touch spaces like break rooms or bathrooms. And everybody has much higher confidence that the office is a safe space. They're not as worried about sneezy Jane, even in flu season. And people can now choose the spaces that work for them based on characteristics, including noise and light. So that's an example of kind of an ideal scenario where different systems are working together. The air quality and the HVAC and the occupancy are all working in tandem to deliver value to the organization. So hopefully that gives you a sense of what it feels like to be at different levels and gives you a sense of maybe where you fit and some of the benefits of moving to a higher degree of maturity. So I want to leave you with some things to keep in mind as you're planning a sensor deployment. First of all, think about scalability and total cost of ownership. The total cost of ownership of a program like this can vary up to 5x across vendors based on some of these characteristics. First of all, what's the right mix of sensors that you need? Everybody's use case is different. Some people have a lot of open office space with lots of desks where they want to actually make sure they know how many people are using those desks. In that case, all you need to have a desk level sensor, and those sensors are much, much cheaper than a room sensor. So if you install room sensors for that use case, you're actually going above and beyond what you need and spending a lot more money to get there. In some cases, you're concerned about whether people are in a space at all versus counting how many. Again, presence detection is cheaper than counting. So that's, again, a situation where you might be going overboard. And similarly, in some cases, you only care how many people are coming in and out of a whole floor. You want to know, for example, how much food to order for the cafeteria or the break room. You don't actually need to know where people are. You just need to know how many people are coming in between 8 and 9 and leaving between 4 and 5. So that, in that case, you only really need to count at the threshold. So again, you might be overdoing it to deploy a lot of sensors if that's really the use case that you're driving. So having the right mix and a number of sensors for your use case is one of the most important things to think about when it comes to total cost of ownership. And of course, total cost of ownership is what determines whether you can do this in one area or across your entire organization. Secondly, networking. If you have one vendor for air quality and a different vendor for occupancy and a different vendor for environmental monitoring, you're going to end up having 3 parallel networking infrastructures, 3 times the cost. So if you can get all of that from one vendor, you're going to reduce the cost of that networking infrastructure pretty significantly. And the ratio of sensors to networking matters. Some vendors require a networking point for every 5. Some vendors require a networking point for every 100. So that's going to really change the cost of this part of your program. Installation is another big deal. If you're installing electrical to power your sensors with a hardware connection, that's going to drive up the cost of installation very significantly. If you are installing wired networking, similarly, that's going to drive up the cost of your installation. If you're not using electrical wiring or networking, you're going to need to swap out the batteries. If you have to do that often, that's going to cost a lot in maintenance. If your battery lasts 5 or 10 years, you may never have to do it. And then you're avoiding that maintenance cost. So there's a little bit of sometimes a trade-off between installation cost and maintenance cost. In addition to that, some vendors require you to come and calibrate sensors, especially air quality sensors. And some of the standards, building standards, require calibration. So if you don't have auto calibration, that's something else that is going to require and drive up your maintenance expense. All in all, factoring in these factors can really change the cost of ownership pretty significantly. So it's important to think about them. Security and privacy is another really important thing to consider. And I know a lot of people have that pretty top of mind. In general, at least speaking for R0, as I said before, we do not know or have any way of knowing who is in the space. We don't know individuals. We only count the number of people or whether anyone is in a space at all. And you can be assured of that because there's very little data that's actually transiting the network. And that is an intentional choice that we make in order to be able to deliver you a battery-powered sensor that lasts, where the battery lasts a long time. So that's a fundamental architectural constraint of how we have built our product. It's not something that we could change even if we wanted to, because that would require so much more data to send images. It would require so much more data, and our battery life would get very short if we did that. Because of that, we process images on the device and destroy them. We don't want to have to bear the cost of storing them. We immediately determine how many people or laptops are in an image, and that's the only data that is kept and passed along. Now, I want to also talk about the fact that it can feel like what we want from our buildings is contradictory, or that there are really significant trade-offs between our objectives. So what do we want our buildings to do for us? We want them to help us flourish. We want them to be sustainable, and we want them to be efficient. Flourishing is about making us productive, ensuring our safety. Sustainability is about lowering emissions, and efficiency is about reducing the amount of space that we need, if possible. It's about ensuring that our mechanical systems last as long as possible and save us the cost of replacement. But these goals sometimes contradict. There is a trade-off sometimes between healthy ventilation and how much energy use and emissions come from that. If you crank up the ventilation in the HVAC, of course, that uses energy. There's a trade-off between comfort and productivity. You can give everybody a private office of 400 square feet, but of course, that's going to take up an enormous amount of space and cost you an arm and a leg. there's a trade-off between efficiency and sustainability, because a lot of the investments that you want to make to improve sustainability, like upgrading your HVAC or your insulation or your roof, are really expensive. They can be very capital intensive. So it can be difficult to have your cake and eat it too. But it's our experience that if you have a more coordinated approach, and this is really what that level 4 of the maturity model is speaking to, if you can have a really coordinated approach, you can do a lot to reconcile these conflicting goals. You can have a building that helps you flourish and be sustainable by using occupancy data to match ventilation to people much more precisely, while indoor air quality ensures a floor and essentially provides an insurance that you're never going to reduce ventilation so far that it's impacting people's comfort and well-being. And if you add UV disinfection to that to inactivate pathogens, that's a bonus. Now you're reducing any infection risk and providing enough air for people to be healthy and comfortable, but no more than that. You can be flourishing and efficient if you use occupancy data and calendaring and booking to maximize the utilization of the spaces you have and adjust the mix of those spaces over time, or in a hospital to spot people who might have fallen out of bed or haven't moved in a while and need to be turned. That can help you reduce the amount of interruption for those patients and only come in, instead of just to check on that, only come in when necessary. That also saves nurses time. So you can increase efficiency and help people flourish. And you can be efficient and sustainable. So if you use software to make the most of the systems you already have to reduce energy, that means you avoid all of those big CapEx expenses. You can also use software to take a really good portfolio approach to the kinds of projects and the kind of initiatives that you choose to invest in. There's a really interesting McKinsey study that came out late last year that talks about that and really shows how you can turn a negative NPV building project portfolio to improve sustainability into a positive NPV project. So I encourage you to go look for that. As we wrap, I want to just quickly touch on R0. So R0 has a portfolio of hardware products that include UV disinfection, that include counting, that provide presence data. A number of our UV disinfection products also provide presence data, and also air and environmental quality data. Our hardware, we think, is terrific because we have a mix of types of sensors. We can provide you the right sensor for every use case, whether that's floor and room presence, whether that's counting, passive occupancy, environmental quality and air quality. We can provide you the right mix of sensors, all anonymous, all with best-in-class security and onboard AI, and provide you real-time data to help you and your organization make decisions and inform how people work in real time. And we do all of that with the lowest cost of ownership. We're wireless, so that cuts your install costs dramatically. Our batteries last a long time, so your maintenance costs are minimized, and you can get a single networking layer for the entire platform so that you don't have to duplicate that. And from a software perspective, we provide you with unified analytics so that you can do the kinds of things we talked about of combining indoor air quality and occupancy in order to deliver better outcomes all in combination. And our software layer is designed, software and hardware layer is designed to be able to deploy and get moving really quickly. So as compared to a retrofit of physical space, which requires permitting, which requires construction and can take months and years, you can get going in literally weeks with occupancy or indoor air quality data. No retrofits required, no permits required, and get value very quickly. Our whole approach around software and hardware is to deliver a consumer level experience that's easy for people to use, that's easy to understand, that doesn't require any special expertise or staff or training, and it's open by design. We know that there are more and more sensors available, that there's more and more opportunities to integrate with building systems, and we want our system to work well with other systems and other data and connect to other enterprise systems you might have, calendaring, etc. So our system is designed to be very open and modern to make it really easy to work with. This is just an overview of all of the different kinds of things that we offer around efficiency, health, and sustainability. And we work with a great number of fantastic partners across a variety of different industries. And we're really grateful for their support and engagement and partnership in helping to make our spaces more efficient and productive and healthy for everybody. Thank you for joining today. We wish you all a wonderful rest of your day.